Let's consider the same example and a slightly different way of applying it. Using the technique described in this example, with a little practice, you'll soon be able to do them in your head. Let's start by considering y equals 2x plus 3 to the 50. If we look at this as a compound function, the x first goes into the 2x plus 3 function and then comes out and goes into the x to the 50 function. From the first function, the output is 2x plus 3, and this is input to this function, so we get 2x plus 3 to the power 50. So this is the first function, or in this instance called the inside function. This is the second function, and for this purpose we call it the outside function. If you look at the brackets above, you can see that the inside function is inside the brackets. However, this isn't the case in all examples, so one has to be a little careful. But if you think of the first function as being the inside function and the second function as being the outside function, then you can't really go wrong. The technique then is that we first differentiate the outside function. We do this treating the inside function as if it is just x. You'll see what I mean when we actually do some examples. We then multiply this by the differential of the inside function. So let's look at that in this case. We differentiate the outside function. Remember, treating the inside function as if it's just x. So basically we differentiate treating the bracket as if it's an x. We know that if we had y is x to the 50, dy dx would be 50 x to the 49. Compare that with this expression and you can see the inside of the bracket has been treated as if it is just x. In essence, we've just differentiated treating the whole bracket and the function within it as an x. We then want to differentiate the inside function, which is 2, and then we get 100 times 2x plus 3 to the power 49. With a little practice you really can do these in your head.